Welcome back. Here, we're going to zoom in to where the lower motor neuron meets the muscle. Each alpha motor neuron extends its axon to contact individual muscle fibers, and each neuron contacts up to approximately 200 muscle fibers. The motor neuron, together with all the muscle fibers it controls, is called a motor unit. When that motor neuron fires, all of its fibers contract together as one coordinated unit. The phrase "up to 200" is clinically meaningful because motor unit size varies considerably throughout the body. In muscles requiring extreme precision, such as those controlling eye movements, motor units are very small, with just a handful of fibers per neuron, allowing for fine, delicate adjustments. In large postural muscles that generate bulk force, motor units are enormous, with many fibers per neuron. Each motor unit contributes its own specific force, and the nervous system grades overall muscle strength by varying how many motor units are recruited at any given moment and how rapidly they fire. This produces smoothly graded force output rather than all or nothing contractions, which is what allows the same arm to hold a pen delicately or lift a heavy object. The concept of the motor unit is foundational to clinical neurology. When a motor neuron is lost, all the muscle fibers belonging to it lose their nerve supply simultaneously. When multiple motor units are lost, weakness becomes clinically detectable. When enough motor units are lost or denervated, the muscle can no longer generate meaningful force at all. In summary, a single motor neuron branches to innervate multiple muscle fibers, and that entire set functions as one motor unit. The lower motor neuron cell body is in the anterior horn of the spinal cord for somatic muscles or in the brainstem for cranial musculature, with a myelinated axon projecting to muscle and forming neuromuscular junctions. Extraocular, finger, and other precision muscles have few fibers per motor unit, while larger muscles, such as biceps or quadriceps, may have very large motor units for strength generation. As more force is required, motor units are generally recruited from smaller, lower force units to larger, higher force units. Electromyography (EMG) evaluates motor unit electrical activity during insertion, rest, voluntary contraction, and recruitment, helping localize weakness to the anterior horn cell, nerve root, plexus, or peripheral nerve, and can also detect muscle disease. Lower motor neuron disorders can produce muscle wasting, fasciculations, flaccid weakness, and reduced reflexes, while chronic denervation can enlarge surviving motor units through collateral sprouting, producing long-duration, high-amplitude, polyphasic motor unit action potentials on EMG. In the next video, we will go over plexus reorganization and clinical localization of weakness.